Welcome back. In this tutorial, we're going to finish up the body of the ramp car, and what we're going to do is go ahead and add the top. So I'm going to start a new part. We're going to save that as the top. And we're going to sketch, obviously, on the top plane, rotate it so that top reads correctly, and do a center point rectangle. And I'm just going to throw in a couple of dimensions here and extrude it. And what we're really going to end up doing is just taking this part, popping it into the assembly, and working on it in there because we got to get some dimensions off of our car. So we'll go ahead and fix the O in top and then place that. Now this part is the same length as my bottom, which if we are to rotate it and then drag it, we can see that it's going to be a little bit short, which is no big deal. So we need to go ahead and measure the distance along this edge, and it is 6.083. So now if we double click our top, edit our extrusion, change that, finish sketch, and we're good. So now we need to put notches in before we can obviously assemble these. The question is, which notch are we going to put in? So I'm going to go ahead and put all the notches in the body of the car that's already existing and then correspond to that with the top. So we're going to go ahead and we're going to click on front one, sketch, and then we're going to come back and going to do a little bit of creative work here. Now, I cannot use a rectangle because those only go horizontal, so I have to draw it in. And so my angle here, I'm just going to draw in the shape. Really, really rough. It's not even connected. So I'm going to project geometry and then extend that first. Draw a line between those two. Now, what constraints do I need? Well, I could use a perpendicular between these two and between these two, and it already exists, so that's good because these two are probably parallel. If we hit F8, we can see that indeed they are parallel, which is good. So now I want a parallel constraint between this and this on the bottom. Now we've got our notch square 90 degrees relative to that angled face. Now we can come in and put in an aligned dimension of notch. And if you look really carefully, as you move closer to the line, I get that kind of aligned symbol to the right of my cursor. I know it's hard to see, but if I move straight out, I get a vertical. I want to make sure this is an aligned dimension. The other thing I can do is right-click aligned, and then I can put this in equal to notch. Now, the distance from here to this point is going to be equal to notch times 2, and I want to see how that looks. It actually looks pretty good. So we can go ahead and finish that. Extrude that as a cut through all, and go ahead and pattern it. And let's see, we probably need, was it 24 of those? 23. Okay. So that looks good. And so now, since we started working back here, it only makes sense on our top piece to start working back here as well. So we're going to get that started, and then we're going to finish up with the front and the back, or the left and the right, whatever we're calling these two. So to start, we'll double click our top piece. Look at our top view. Now notice that we see a little bit of that edge because we're looking normal, 90 degrees to this angled face, which is what we want. So now I can sketch on here. And now I can draw in my 2-point rectangle. Oh, there we go. So notch equals 0.125, right? Because we haven't done that in this part yet. So now we can do this. We can say notch times 2. Set this to be equal to the notch. And finish and extrude through all. Rectangular pattern then of that extrusion, just like always before. And we'll go with 22 on this. Nope, 24 is going to be. 23 is the answer. Okay, so that looks good. So we're going to go ahead and OK that. And then while we're in here, let's just go ahead and mirror that pattern about our Y or XY plane. And voila. So now we can come in and start to put some constraints in here. So let's put a flush between these two angled faces. And if we slide this over, what's the best way to get this aligned in here? So we see that this is on an angle relative to this. So I would say that our best way to do this would be to do a flush between these two notches here. Nope, sorry, that needs to be a mate. Let's go back. All right, so we're going to do a mate because we want this face here opposed to this face here as opposed to aligned. And now our part is too far in, so we can do a flush between our outside faces and that. So now we see that I am one notch in with my other constraint. So let's go ahead and take this mate, and we're just going to delete this real quick. We can edit it, but it's easier to just delete it. So if we get this lined up, now we want a mate between this face and this face. So sometimes you got to, take a look, back up, see what's going on, take another stab at it, and kind of go from there, right? So now we've got some interference here. So we need to go ahead and put another cut in our top piece right here, which is no big deal. Actually, what we can do is let's go take the end of part and drag it above the mirror and put in just another quick rectangle, notch and notch. Finish that, extrude that through all, and we're going to go down and drag Okay, end of part didn't move, but that's okay. So we're going to put the extrusion above the mirror. Sometimes it works better if you drag end of part up. And the reason we did that is because now in this mirror, we can go ahead and include this extrusion here. So now if we return, we can see that that looks pretty good. Now the question is there interference between this piece and this piece here? So let's go ahead and do a quick interference analysis. I'm going to say there is. Yep, we see that little triangle right there, right? So what that tells us is that by some distance, we have to cut off the top piece. Now, to make Inventor happy, we could cut this on a taper, but that's not really going to give us what we want because in the laser, we can't cut a taper. So all we're going to do is come in here and just for the sake of time, I'm just going to do this quickly. This is not super critical to your design. So what we're going to do is we're going to throw a rectangle in here, and I'm going to dimension that rectangle. Let's try that again. Dimension this rectangle. Let's call this 0.05. Extrude that as a cut through all, and that's probably going to be on the big side, which it is. Okay, so now we can do a measurement between this line and this face, and we see that that is 0.027. So if we come back into our part, take that dimension, so we can push it 0.027, which would be 0.0. Let's try this and see if my math is right. So let's do that interference check again. Perfect. So, and remember too, when we laser, it will cut a little bit off. So now the issue is I don't have any way of hooking these two up. I would go ahead and say that that's fine like this. You're going to have a lot of surface area to glue in here. If you wanted to, you could put slots in here, stick tabs out, and mate the two. The problem is you're going to have to leave them a little bit short so that it doesn't stick out. So I would say the way to do that would be to take a measurement between this face and this line here, and then instead of 0.125, actually you could use a 0.125 tab, and then it'll come in a little bit shy of this, which would be fine. And then down here, we're going to do the same thing. You're going to go ahead and you're going to put a cut in here to make this face not interfere down here. And if we do an inspection of our interference, we're going to see that indeed the last interference that we have looks to be here. Now it's saying 3, so if we go to wireframe, it's a little more handy. So it's 3 parts that are interfering: the side and the top and the front. So we can go ahead, we can adjust those and finish this up. Thanks, and we'll see you in the next video.